now, during the halogenation of reaction, we show that a molecule of methane react with chlorine or bromine or fluorine. It produces a substitution reaction, substitution product, that is CH3Cl, CH2Cl2, CHCl3 and CCl4 carbon tetrachloride, and the counterpart of the bromination and fluorination and halogen does not take place. Iodination does not take place. So what are the reasons behind this? All the answers are rooted in the reaction mechanism, and every reaction mechanism is a guess. Okay, it is a hypothesis. It is it cannot be proven. Okay, so best it is the best possible way to explain any reaction and reaction condition. So it is important for us to know not only what happened in a chemical reaction but also how it happened, and it is not only fact but also the theory. Okay, for example, we know that the methane and chlorine under the influence of heat or heat or light to form what we say that methyl chloride and hydrogen chloride. Just how a molecule of methane converted to the molecule of methyl chloride, does this transformation involve more than one step? Okay, or so what are these steps? If it is more than one step, what are these steps? And just what is the function of light or heat during this reaction? Okay, so the answer of these questions, that is a detailed step-by-step description of a chemical reaction, this is known as reaction mechanism. So reaction mechanism is detailed step by step, okay, step by step analysis, right? So description of chemical reaction, description of chemical reaction. So all the reasons are rooted in this, that is the reaction mechanism. It is only a hypothesis, as we already said. It's advanced to the account for fact. That is, reaction mechanism explain why these facts happen, why CH3Cl formed, okay, and how it is formed. So the many fact we encounter in the halogenation or chlorination. First fact is the reaction involved methane and chlorine do not react in dark. So if we react methane with chlorine, it doesn't react in dark. So why? But if methane react with fluorine, right, it react in dark. What is the reason behind this? Okay, what is the reason behind this? The first fact, which this is the fact, and this fact is established by a well-known description, that is called the reaction mechanism. Okay, now reaction take place if, second fact is, if CH4Cl2 and we provide it light, or we heat the mixture at 250 degrees Celsius to 400 degrees Celsius, it produce CH3Cl. So by mere heating the reaction mixture at 250 degrees Celsius to 400 and in presence of ultraviolet reaction, chlorination take place. Why? Again, reaction mechanism, the steps involved, get the clear solution and clear explanation, not the solution, clear explanation of this fact. Another fact is under the ultraviolet presence. So if either heating or either under ultraviolet light reaction takes place. The next fact is, when the reaction is induced by light, many molecules of methyl chlorides are obtained. for each photon of light that is absorbed by system. So one photon of light may produce many molecules of CH3. So why one photon is requirement? There is only one photon or few photons or few ultraviolet light photons are required to increase. That is the chain reaction involved in such type of reaction. This is the fact, and we again move to such a description, that is the reaction mechanism, which explain this type of the fact. Now, in the presence of a small amount of oxygen, if in this reaction mixture, if we have a small amount of oxygen, the reaction take place very slow. And again, why a small presence of oxygen reduce the rate of reaction? All these facts must be explained by the reaction mechanism. I hope you understand what is the role of reaction mechanism. So the mechanism that accounts for these facts more satisfactorily is generally accepted. So the first reaction mechanism is C in the reaction mechanism is chlorine. So chlorine, when induced with heat or light, so it is homolytic, undergoes homolytic fission. So we get two atoms of chlorine. So this is homolysis. Okay, homolysis. So here lysis, here the role of ultraviolet light or heat is to the breakdown, that is the supply of energy in order to break the bond between chlorine and chlorine. So energy must be provided in order to break the bond between chlorine and chlorine. Now this chlorine, here we find the role of heat and light, that is the heat broken the ultraviolet light, broken the chlorine bond, and we get 2Cl, that is free radical. Now one of Cl atom attack like such that with methane, and again in the excited state and energy provided, there is again homolytic fission between carbon and hydrogen, and we have C here. This is very important. We have intermediate step HCl if this bond is broken, and CH, and this one. So this Cl atom and this hydrogen atom combined up make HCl, and again we have free radical, that is methyl free radical, that is CH. So this is formation of methyl free radical. Now this methyl free radical again react with which one? Chlorine. So we have CH, and we have chlorine atom. So we can write here homolytic fission again. So again this chlorine we have formed here, it is formed Cl and Cl, and one of the methyl radical is reacted with one of the chlorine atom, and it produces CCl, CH, and H, and again Cl. So here whatever the Cl formed, this Cl is again formed, chlorine atom is again formed, and again the step goes like that is if we term it is step 1, this is step 2, and this is step 3. Again the step is Cl again attacked with CH4, again step 2, step 3, right, step 2, step 3, step 2, and step 3, until the concentration of CH4 is goes down, and finally, right, and finally the product is formed, that is CH3Cl. So this is the mechanism of what? Free radical chlorination. So the chlorine molecules undergoes homolysis, that is cleavage of chlorine bond take place in symmetrical way. Homolysis means broken of bond in the symmetrical way, so that each atom retain one electron of the pair that form the covalent bond. The odd electron is not paired and are all the other electrons of the chlorine atom. That is, it does not have a partner of opposite spin. and if have not the partner of opposite spin, so this is called free radical, and it is very reactive, and due to reactivity it again get the opposite partner, that is at electron in opposite spin from where, from CH4, and when CH4 is when there is homolysis between C and H, methyl free radical is formed. So this reaction goes and goes. I think you have cleared the concept of what is the reaction mechanism. Now see here, in mixture we have chlorine. See here, in mixture we have chlorine, we have Cl free radical, and we have CH3 free radical. Okay, these are in the mixture. So further Cl may be attacked to Cl and resulting Cl free radical and Cl2, either in this way. So this Cl and Cl attack and the Cl2 is formed. So this is not the productive one. But what happens if another free radical, another type of free radical goes on in the system? So at that type, that free radical react with the another free radical which is not in the system, that is it is provided from the external sources, and when such type of free radical come in the system, this Cl consume at the cost of the external provided free radical, which turns of the reaction goes down and acts as an inhibitor. So we have a fact that when oxygen is added, reaction is too slow. So oxygen there acts as an inhibitor. And one more thing is here, we have CH3, we have CH, H and H free radical. So it will also attack to another such type of free radical to join. However, this reaction is rarely happen, or it is very in slow concentration. So such type of product is also be formed in minor. So major product is CH3Cl. These are the basic concept. I think you understand the concept behind the free radical mechanism and why such type of free radical mechanism happen, and what is the role of light and heat. This will explain in the energy of activation, why some energy are provided in order to proceed the reaction. The answer is energy of activation. So in the next lecture we will see what is the energy of activation and why it is required to proceed any type of free radical substitution and any type of chemical reaction. So our next target is activation energy and progress of reaction. This is a very easy, a very basic concept which you must learn in order to grasp the concept of organic chemistry. This is starting. Okay, so you must go through a textbook which enhance your capability to learn the concept very deeply. I hope you understand the concept. So we stop here. Have a nice day. Jai Hind.